Good evening. Today we'll discuss limits and derivatives. Yesterday, while concluding, I have spoken to you, rather informed you that the 7 standard limits I will not be writing because I have discussed that while discussing question papers. So today directly I will be moving on to the problems of limits. Okay. Let me start with the first problem. Limit extends to 0. 1 minus cos x by x square. This is a standard problem. If you can remember, this has also a standard limit. 1 minus cos x by x square is equal to 1 by 2. Limit extends to 1 minus cos mx. 1 minus cos mx is equal to m square by n square, or just limit extends 0. 1 minus cos x by x square is m square by 2. So these three, if you can remember as standard limits, you can save a lot of time. You can save a lot of time if you can remember this. But let me work also how to get the solution for this. Limit extends 0. 1 minus cos x is 2 sin square x by 2 divided by x square. 2 can be kept outside. Limit extends 0. Sin x by 2 by x whole square. See, while discussing, I had given you this formula. Limit extends to of f of x to the power of n is limit extends to a of f of x whole to the power of n. All these formulas I have discussed while I was revising the question papers. You can go through that. Okay. Now we have got x by 2, so we shall have, because whatever we have, what is the standard limit? Standard limit is limit theta tends to 0. Sin theta by theta is 1. If you have got alpha here, you must have alpha here. If you have got alpha by 2, you must have alpha by 2. So x by 2, I need x by 2. Therefore, to compensate that, I will multiply by 2. So this will be equal to 1. Therefore, answer is 2 into 1 by 4. That is 1 by 2. What I would advise is remember this. Cos mx by cos mx by nx is, supposing they give you limit extends 0, 1 minus cos 6x by 1 minus cos 4x. In fact, I think in 2015 or so, they have given this problem. You can remember the answer as m square by n square, that is 9 by 4. Along with those 7 standard limits, you can remember this, you can save a lot of time. So let me go to the next problem. Today I am just working out the problems that have been asked in the previous year's question papers. The briefing, I have not spent any time on that because I told you already while doing that revision of or rather while working the previous year's question papers. That time I have discussed all this in detail. The next problem is limit x tends to 0, x e to the power of x minus sin x by x. How to work this problem? Immediately it should come to your mind the algebra of limits x tends to a f of x plus or minus g of x is equal to limit x tends to a f of x plus or minus limit x tends to a g of x. So what we can do is limit x tends to 0 e to the power of x minus limit x tends 0 sin x by x. In fact, there is no need of writing the orally, we can do it. 0 e to the power of 0 is 1 and sin x by x is 1, therefore answer is 0. I have written the steps, but while working problems here you can just see separated, you get e to the power of x by x. E to the power of x by x. That is x and x will cancel, e to the power of 0 is 1. And then sin x by x. That is also 1, 1 minus 1 is 0. Another year, there was the problem. Limit x tends to 0, root of 1 minus cos 2x by x. So here you cannot use that formula, I have got to simplify this. What is 1 minus cos 2x? 2 sin square x. So this is root 2 sin x. Sin x by x is 1, therefore answer is 1. You did not work out, looking at it you can say it is root 2 sin x by x is 1, therefore it is root. Another year, almost similar, I just want to discuss similar problems. Limit x tends to 0, limit x tends to 0, sin of 2 plus x minus sin of 2 minus x is equal to by x is equal to a cos b. A cos b, when a and b equals, then a and b equals. Now I have given 4 answers. As I told you earlier, I am not listing all the 4 answers. We will be just working the problem. The moment you see this, you should remember you have got to use the formula sin c minus sin a. That is 2 sin c plus d by 2. Sorry, first cos because there is a minus sign. Sin c minus d by 2. So this is, don't waste time writing limit and all that. 2 cos 2 plus x minus 2 minus x. X and x will cancel. You get cos 4 by 2, that is cos 2. C minus d, you will get sin x. Sin x by x is 1. Therefore, a is equal to 2 and b is equal to is the answer. These problems will not take more time, provided you remember the method. Another year, there was a similar problem. Limit extends to A, sin square x minus sin square A by x square minus A square. Normally, we just get an idea, we can use the formula sin of A plus B into sin of A minus B is sin square A minus sin square B. But there are some problems which takes more time. And once you notice that a problem involves more time, that means you have got to use formula and simplify. There's a method called LH rule. What is LH rule? Yesterday while closing class I have discussed, you can differentiate numerator and denominator and put the value to get 0 by 0 again or infinity by infinity or in a simple word indeterminate form. Can go on differentiating until we get the answer. So let us differentiate this. Limit extends to 0. What is sin square x? It is sin 2x by 2x. I always tell students, remember, y is equal to sin square x, dy by dx is sin 2x. Don't write 2 sin x cos x and then sin 2x. Y is equal to cos square x, dy by dx is minus sin 2x. So this is all very shortcut method. So y is equal to sin square x, it is sin 2x. Y is equal to cos square x, it is minus sin 2x. So what is this? This is equal to 1. Because sin m theta by m theta is equal to 1. Sometimes they give a problem like this. Limit extends to pi by 4. Sin x minus cos x by x minus pi by 4. These are all special problems which are not in the standard form. The method for this is, normally you can play a game. Put the denominator equals theta. X minus pi by 4 is equal to theta. If x tends to pi by 4, theta tends to 0. The problem becomes theta tends to 0. What is x? Then x is equal to pi by 4 plus theta. So this is going to be sin pi by 4 plus theta minus cos pi by 4 plus theta divided by theta. There is no formula sin c by sin a minus cos a or cos b. You got to expand this. It is root 2 cos theta plus root 2 sin theta minus root 2 cos theta plus root 2 sin theta divided by theta. Sin A is sin pi by 4 is root 2. See that this much you must go do it fast. Don't write sin pi by 4 then. I'm sorry. Sin pi by 4 is 1 by 2. Not just 1 by 2. Now, what is the answer you are going to get? These two will cancel. You get 1 by root 2 into sin theta by theta. That is 1. Therefore, answer is 1 by 2. There are problems of limit n tends to infinity, limit n tends to infinity, 2n square plus 3n plus 4 divided by 5n square plus 4n plus 2. So if you can remember, the answer is 2 by 5. You can always remember, if the coefficient of numerator and denominator are same, the answer is the coefficient of numerator and denominator n square is 2. Supposing numerator the coefficient is more, or denominator coefficient is more. So let me work all the problems and give you the method. See, what is the method? We divide by n square. 2 plus 3 by n plus 4 by n square, 5 plus 4 by n plus 2 by n square. When n tends to infinity, 1 by n equals 0. These two are 0. 2 by 5. Supposing you have got n cube here, so you are dividing by n cube. So what will happen is you will get 5 by n here. So numerator is 2, denominator is 0. The answer is infinity. Supposing denominator is more, let me repeat. The numerator degree is more than denominator. If both are same, it is the coefficient of the highest term. That is 2 by 5 in the previous case. Suppose the numerator degree is more than denominator. You are dividing by n cube instead of n square. So what will happen is, you will get 2 here and 5 by n. 5 by n is 0. 2 by 0 is infinity. On the other hand, if denominator cube is more, so you will get n here and you will get 5. So you get 0 by 5, that is 0. So you can remember like this. Both the degrees are same. The answer is coefficient of the highest degree of numerator denominator. If denominator is highest, then it is 0. If numerator degree is more, then it is infinite. So that you can work such problems. But I have collected 1 or 2 problems of the same type. So let me take one problem. Limit n tends to infinity. Limit n tends to infinity. 1 square plus 2 square plus 3 square plus etc. plus n square over 4n cube 6n square minus 5n plus 7. So you are going to decide. This is 4n cube 6n square. So what is the degree of numerator you are going to decide? So you should remember these formulas. Sigma n is n into n plus 1 by 2. Sigma n square is n into n plus 1 into 2n plus 1 divided by 6. Sigma n cube is n square into n plus 1 whole square by 4. So this is sigma n square. What will happen is, limit n tends to infinity, n into n plus 1 into 2n plus 1 divided by 6 into 4n cube plus 6n square plus 5n. See, when you multiply, you are going to get 2n cube. This is 4n cube. Therefore, answer should be 1 by 6 the constant. This 2 by 4. The answer is 1 by 12. I repeat how we worked out. I have used the formula. I know this is going to be n cube. It is 2n cube. Other terms you are not interested. Whether it is 6n square, 4n square, we are only looking at the highest degree. So it is 2n cube. And this is 4n cube. Previous problem I explained, both the degrees are same. Coefficient of 2, n cube is 2 and 2 by 4. 1 by 6 is a constant, therefore you get 1 by 12. One more problem similar to this. Limit n tends to infinity. N tends to infinity. 1 to the power of 99 plus 2 to the power of 99 plus 3 to the power of 99, etc. plus 100 to the power of 99 divided by n to the power of 100. It's a peculiar problem. Very easy if you have worked it out earlier. What you can do is, you can write this as limit n tends to infinity 1 by n to the power of 99, 2 by n to the power of 99, etc. 100 by n to the power of 99 into 1 by n. Because n to the power of 99 is here, and these are all zeros, and 0 into 1 by n, the answer is 0. 0 by infinity. It's a very simple problem, provided you understand that. There's one more problem similar to this. Limit n tends to infinity of 1 over 1 minus n square plus 2 over 1 minus n square, etc. n over 1 minus n square. These are all standard problems. It's a normally repeated examination and they're not difficult. Only thing is understand what the problem is. This is nothing but 1 plus 2 plus 3 plus etc. plus n over 1 minus n square. That is nothing but limit n tends to infinity of n into n plus 1 by 2 into 1 minus n square. N square coefficient is 1, here also 1, therefore answer is minus half. It's not minus, plus half. It is half. Because the coefficients, it is minus half. Because you are going to get minus 2n square and n square here, minus half is answer. We have a similar problem asked in the examination. Sigma is just to confuse it. When you look at the problem, you think it is difficult. R is equal to 1 to n. 2r minus 1 is equal to x. It is given. Then, the moment you see sigma and all this, you find it is difficult. It's a very simple problem. And most of the problems in the previous are repeated in previous papers. That's why if you work the previous papers, then you will not have any difficulty and immediately you should be able to recall. So they have given this. Then the question is limit n tends to infinity of 1 cube by x square, or it extends it there, by x square plus 2 cube by x square plus etc. n cube by x square. This is a problem. So you should understand first